Alright, welcome to this class. Let's consider change of states. Students should always be aware that the three states of matter are interchangeable. That is, they are interconvertible. What do we mean by this? We mean that solid can change to liquid and vice versa. So it means when solid changes to liquid, liquid can also change back to solid. It's possible. Similarly, liquid can change to gas and then gas can change back to liquid. And finally, solid can change directly to gas and gas can change directly to liquid, solid, without passing through the liquid stage at all. So all of this is what we call change of states. So we also call it phase transfer. So it is called phase transfer. Now, and the processes that are involved in this change, for instance, if solid is changing to liquid, there is a process involved. If liquid is turning back to solid, there is a process involved. All those processes involved are known as phase transfer processes. So we call them phase transfer processes. So, but before we talk about phase transfer processes, I want us to be aware that for all of the forward processes in this diagram, we need heat. And for the backward processes, we need cooling. So how do I mean? That is, going forward, when we are converting from solid to liquid, we need heat. Of course, we must supply it to a solid before it can melt down to liquid. Similarly, from liquid to gas, we need heat. Similarly, from solid to gas, we must supply heat. But when we are going backward from liquid back to solid, we need cooling. That is, we must remove heat. Similarly, from gas back to liquid, we must remove heat. That is, we must lower the temperature. Then from gas back to solid, we must remove heat. The temperature must fall. But going forward, the temperature must rise. So now let us consider the phase transfer processes. I'm going to display each one of them in a triangle. This triangle is called phase transfer triangle. Now, here is the phase transfer triangle. So this triangle is showing the processes involved when all these three states of matter, when they change interconvertibly. That is, when matter changes from one state to another. You can see when matter changes from solid to liquid. See where the arrow is pointing. So, and the process involved here is melting, or we call it fusion. So we say that a solid can melt down to liquid. So the temperature at which solid melts to liquid is known as the melting point of that solid, or we call it the fusion point. Similarly, liquid can turn to gas, and the phase transfer process involved in that is called boiling or vaporization. Now, the temperature at which liquid boils down to gas is called boiling point. So that is the boiling point of the liquid. For example, the boiling point of water is 100 degrees Celsius, and the melting point of ice is 0 degrees Celsius. Now, when solid turns to gas without passing through the liquid state at all, so that process involved is known as sublimation. Sublimation. So there are some substances that can undergo sublimation. So example is dry ice, which is solid CO2. And then we have iodine crystal, which this can also turn straight to gas without passing through liquid state, and many other ones. An example is camphor too. Camphor can also turn straight to gas without passing through the liquid state. Now, when liquid turns back to solid, the process involved is known as freezing or solidification. Similarly, when gas turns back to liquid, the process involved is called condensation or liquefaction. You can see how the arrow is pointing. Then gas back to solid. This is known as deposition. However, all of the forward process that we have here, they require heat, while the backward arrow, they require cooling. So that means melting of solid to liquid, we need heat for that. Then vaporization of liquid to gas, we need heat. Similarly, sublimation of solid to gas, we need heat, while deposition of gas back to solid, we need cooling. Similarly, for liquid to turn back to solid, we need cooling. Similarly, for gas to turn back to liquid, we need cooling. So in short, for the forward process, we need heat, while for the backward process, we need cooling. However, certain things need to be considered here. We need to consider certain things here. Or before that, this diagram can be drawn in a linear pattern instead of having it in form of triangle like this. That will also indicate phase transfer processes. Let's see how we can draw it otherwise. So now you can check this new diagram. So this is looking more simpler than the triangle diagram. So from solid to liquid, we have melting, which is also known as fusion. Then from liquid to gas, we have boiling, which is also called vaporization. Then we have gas to liquid, we call it condensation or liquefaction. Then from liquid back to solid, we call it freezing or solidification. Now from solid straight to gas, we call it sublimation. Now from gas back to solid, we call it deposition. So what we have here is just the same as what we have in the phase transfer triangle above. They are just the same thing. So now let's consider some important things to note about this change of state. There are certain things we need to take note of under this change of state or phase transfer processes. Let's see that. So we have some important facts about phase transfer process. Let's consider them one by one. The first one is that there is a substance that can exist in the three states of matter. That's water. So water is a good example of a substance that can exist in the three states of matter. So in solid state, solid water is called ice. So you can see the picture of ice. This is our normal ice block. Normal ice block is solid water. Now, in liquid state, water is called water. That is, liquid water is called water. So you can see the diagram of liquid water being poured from one container to another. Now, water in its gaseous state is called steam or water vapor, steam. So look at this diagram of steam. So when water is boiling, the vapor that comes out of water is called steam. So when water has reached 100 degrees Celsius, it will vaporize and it will be giving out some water vapor. That water vapor is known as steam. See it coming out of the kettle mouth. So this is an important fact that water is an example of a substance that exists in the three states of matter. So we can use that phase transfer diagram to represent the changing process of water. Let's see that. So now, ice can melt down to water. You can see in solid state we have ice and it's melting down to water. So the melting point of ice or pure ice, that's 0 degrees Celsius. So I mean pure ice at 0 degrees Celsius. Then from water to steam. So we need boiling. So we need heat for the forward process. So the point at which water turns to steam is known as boiling point of water. Similarly, for the backward process, we need to remove heat. We need cooling. So steam will condense back to water. That is, gaseous water will turn back to water through condensation process. Then water, the liquid water can turn back to ice through freezing process. So now let us see some other important facts about change of state. Fact number 2. So now the exact temperature at which solid turns to liquid, that temperature is called the melting point of that liquid, of that solid. So for instance, ice can melt at 0 degrees Celsius. So until ice reaches 0 degrees Celsius, that's when it starts to melt. So the melting point of ice is 0 degrees Celsius. I mean pure ice. Now, another important fact is that the temperature at which liquid turns to gas is called boiling point. So boiling point is the temperature at which every liquid turns to gas. So for example, the boiling point of water is 100 degrees Celsius. This is not the same for every liquid. We are just using water as an example because it's one of the common liquid that we have. So until water gets to 100 degrees Celsius, that's when it starts turning to steam. So steam is the gaseous water. So that's 100 degrees Celsius water. However, something can affect the melting and boiling point of both solid and liquid respectively. What's that? Impurities can affect, and then pressure can also affect. But right now I want to talk about impurity first. Let's take that one as fact number 4. So now look at fact number 4. Impurities affect melting and boiling point. So how does impurity affect melting point? It decreases melting point and it increases boiling point. So it means for an ice that is not pure, that is for a solid that is not pure. So let's say the solid contains some impurities. Instead of melting at its exact melting point, the melting point will reduce. For example, if an ice contains impurity, normally pure ice is supposed to melt at 0 degrees Celsius, but because of impurity, it can melt at lower temperature of probably -5, -3, depending on the amount of impurities. Similarly, when water is not pure, that is, if the water contains some impurity, the water will not boil at 100 degrees Celsius. The boiling point will be higher than 100 degrees. It can boil at 105, 110, depending on the amount of impurity. So that is how impurities affect melting and boiling point. Now, another thing that can affect melting and boiling point is pressure. So now let us see how pressure affects both melting and boiling points. Now, when there is increased pressure, that is, when there is much pressure on a solid, it will make the solid to melt faster. So just like regulation process in ice. If we apply pressure on ice, the ice will melt faster. But decrease in pressure will make ice to melt slowly. But that is not the case for boiling point. Now, increase in pressure will increase boiling point, while decrease in pressure will decrease boiling point. So that is, when there is high atmospheric pressure, that means water will boil at higher temperature. It will not boil at 100 degrees Celsius. So if the atmospheric pressure, which is supposed to be 760 millimeter mercury, is no longer 760, if it is higher than that, then water will also boil at higher temperature. But lower atmospheric temperature will also lower the boiling point of water, because when there is increased pressure, we need much more energy to boil liquid. So another fact here is some examples of substances that sublime. What do we mean by that? Those substances that change directly from solid straight up to gas without passing through the liquid state. So some examples of them are iodine, so especially the iodine crystal, which can change directly from the solid state to the gaseous state. So we have sulfur, we have naphthalene, we have ammonium chloride, we have dry ice. Dry ice is solid CO2. So the solid carbon dioxide, when it is liquid, when it is heated, it change directly from solid to gas. Then we have the camphor. Camphor also changes directly from solid to gas. So now here are the pictures of this substance that I listed above. This is iodine crystal. It is black in color. Then this is sulfur. So it is yellow in color. And this is naphthalene. So it's looking like camphor, but there are two different substances. They are not the same thing. So don't confuse both of them. So the difference between both of them will be explained later. So, but the key difference between these two is that this one is made from coal tar. It's a hydrocarbon made from coal tar. While this one belongs to the family of hydrocarbon, organic compound called ketone. So those are organic compounds that have carbonyl group in them. So now, this next one is ammonium chloride. You can see this is also white in color. Then we have the dry ice, which is the solid CO2. This is how the carbon dioxide that we breathe out. This is how it looks when it is solidified, and it can change directly from solid to gas. So all of these substances that we have here, they can change directly from solid to gas. So now fact number 7, the amount of heat required to raise the temperature of a unit mass of a body through a unit rise in temperature is called specific heat capacity, while for the entire body, it is called heat capacity. So I need to explain this a little bit. So now consider this diagram. This is an ice. So I want to use this to explain specific heat capacity and heat capacity. Now for the whole of this ice, let's say the whole of this ice is of mass, let's say 8 kilograms, or let's even choose something smaller like 5 kilograms. So if you want the whole of this 5 kilograms, let's say the initial temperature of this is minus 10 degrees Celsius. So, or let's even use positive temperature like 1 degree Celsius. So now this the mass of this ice is 5 kilograms and the initial temperature is 1 degree Celsius. So now, if we want the whole of this 5 kilogram ice, if we want it to increase, if we want the temperature to increase from 1 degree Celsius to 1 unit, another one more unit, like 2 degrees Celsius, from 1 degree Celsius to 2 degrees Celsius, then the amount of heat required to achieve such rise in temperature is called heat capacity, since that one has to do with the whole of the mass. But if we want only 1 unit of this mass, let's say out of 5 kilograms, we only want 1 kilogram of this. 1 kilogram is just a part of 5 kilograms, which is not the whole of it. So we want only 1 kilogram to increase by 1 degree Celsius, maybe from 1 degree Celsius to 2 degrees Celsius. Then that is called specific heat capacity. So that's just the difference between heat capacity and specific heat capacity. So another fact is the amount of heat required to change the state of a substance without change in temperature is called latent heat. This is another important fact. So when a substance gets to the point where it will change its state, maybe from solid to liquid. So there is, at that point is an equilibrium position where there is no change in temperature. So there will only be, so change of state will only occur there without changing in temperature. So there will be a constant temperature at that point. For instance, when ice gets to 0 degrees Celsius, that's the point where it will melt to water. So at that point when ice is at 0 degrees Celsius, the temperature will not rise. The ice will just melt down to water at the same temperature. So the amount of heat required at that point is called latent heat. Similarly for water, when water at 100 degrees Celsius or other liquid at their boiling point, before they turn to, when they are about to turn to gaseous, to gas, so they also require latent heat to achieve that. And at that point, no change in temperature. The temperature will remain the same. So in this case, latent heat can be classified into two. We have latent heat of fusion and latent heat of vaporization. So now, latent heat of fusion occurs when solid is changing to liquid, while latent heat of vaporization occurs when liquid is turning to gas. So those are just two. We have latent heat of fusion and latent heat of vaporization. Now, with all of these 8 facts, we are able to treat, at least to introduce certain things we will meet in the future in chemistry and physics. So thank you for viewing this. God bless you.